Hello everyone. So here's my project to give detail about the classifiers that I've used in my project. So first of all, for comparing, I've used three classifiers, that is SVM, KNN, and CNN. So for the first SVM, for the first classifier that I've used, this is the code, and I've loaded the data in train data and validation data first of all, and then second, I've split the data into train and validation. I've flattened the images, and then I've trained the SVM classifier and predicted the class. uh, then I've calculated the accuracy and the confusion matrix. So confusion matrix is a table that is often used to describe the performance of the classification model, on a set of test data, or which the true or for which the true values are known to you already. So I've calculated the accuracy and the confusion matrix. This is the confusion matrix, and then I've trained the model and giving it some epochs and just displayed it uh, through pyplot. I've plotted a graph showing the training accuracy and the validation accuracy. So here it is. Then I've used the KNN classifier. So it's this kind of similar process. I've trained the KNN classifier, evaluated the accuracy and the validation set on the validation set. I'm sorry, and then I've given it hyperparameters. Like I've given the values of k. I've given it fixed values of k to find out on which value of k it works the best. Then I've just plotted the validation accuracy versus the k. So here it is, and you can see that it works best for the k for the value 7. So it gives maximum accuracy. And then thirdly, I've used uh, the classification using CNN. So I've set random seed for reproducibility. So then I've loaded the data and split it into train and validation set, as you can see it in this cell. And then I've used train data gen and divided into train data gen and validation data gen. So basically, what this code snippet does is it shows the setup of image data generators using Keras. These data generators are commonly used for data augmentation, so and pre-processing as well. So, and these are used particularly in image classification. So I've used that. Then I've defined the base model using pre-trained CNN. I've freezed the convolutional layers, and then added a few fully connected layers on top of the classification. Basically, what this code snippet does is it has connected layers or added on top of the base model to perform classification. These additional layers actually enable the model to learn patterns and make predictions based on the features extracted by the base model. So I've used ReLU activation. Then I've used the SGD optimizer for optimizing, and then trained the model and given it some epochs. After training, it has given me some values that I've plot using pyplot. So this is the model accuracy. This is the model accuracy and the model loss. So usually, what For image classification, CNN works the best. Uh, that I've found out from my small research that I've done here using the classification models, using three classification models to be precise. Thank you.